All right, let's take a look at our multiplying, dividing rational expressions worksheet. Our review one, simplest polynomial with zeros at 1, negative 2, and 5 would be x minus 1, x plus 2, and x minus 5. We could certainly multiply those things together. That's fairly easy stuff. Let's go ahead and do it this time just to make sure that we're all good at that. So this would be an x squared minus x plus 2x minus 2. So that gives us an x squared plus 1x. When we do the 2x minus 1x is a plus 1x minus 2, and we're multiplying that by x minus 5. Gives us an x cubed plus x squared minus 2x minus 5x squared minus 5x plus 10, which gives us an x cubed minus 5x squared plus x squared is minus 4x squared, minus 5x minus 2x is minus 7x, and plus 10. So there is the answer in its expanded form. All right, what is the domain of this? Well, if there's a domain problem, it's because of this. And so we have to know that the 3x plus 8 cannot equal 0. So 3x cannot equal negative 8. X cannot equal negative 8/3. There is the domain as an inequality. If we wanted to write it in interval notation, it would be from negative infinity to negative 8/3. And jump to the other side of negative 8/3 and continue on to positive infinity, so we could write it that way as well. All right, multiply and state the domain of this. Well, the first thing I'm going to do if I'm multiplying here is try to simplify, if I can, which means factoring all of these things. So let's try to factor the x squared and a minus 2 there. Those are going to multiply together to give me a negative 2 and have to add to give me a negative 1. So a negative 2 and a positive 1 would do that, minus 2x and plus x. So that gives me an x minus 2 and an x plus 1. I'm going to say this is x minus 2 and x plus 1. Let's factor this one down here. So let's see. Got an x squared and a plus 3. Those multiply together to give me a 3 and need to add to give me a negative 4. So sounds like a negative 3 and a negative 1. So minus 3x minus 1x. I'm writing these way smaller than I should. But that one is an x minus 3 and an x minus 1. Okay. If I want to factor x squared plus 3x minus 4, okay, I'll go off on this side and see if I can make my box just a little bit bigger. All right, so I've got an x squared and a minus 4. Those multiply together to give me a negative 4. They need to add to give me a positive 3. So that sounds like a 4 and a minus 1. 4x and minus x. Be an x and a minus 1 and a plus 4. So this is an x minus 1 and an x plus 4. And then finally that one. So I got the x squared and a 12. Those multiply together to give me a 12, and I need a negative 8. Sounds like a negative 6 and a negative 2. So minus 6x minus 2x, x minus 6 minus 2. This factors to an x minus 6 and an x minus 2. I can now read my domain off of these numbers that are in the denominator. I'm going to write this as an inequality. I'm going to say that means x cannot equal, where do we start? Can't equal 1. It can't equal 2, it can't equal 3, and it can't equal 6. Okay. So this is my domain up here. And the answer, I'm going to look to see if there are things that I can cancel. I've got an x minus 1 here and an x minus 1 there, x minus 2 here, x minus 2 there. So what I'm left with in the numerator is an x plus 1 times x plus 4 over x minus 3 times x minus 6. And so this is the answer to the multiplication, probably better in that form than it would be all multiplied together. Okay. So dividing on this one, I'm going to rewrite this problem as I go. So this has a greatest common factor of x. So that will factor to an x times 2x plus 3. I have to factor that denominator. Get a 3x squared and a minus 2, so those multiply to negative 6 and have to give me a negative 1, which sounds like a negative 3 and a positive 2. So minus 3x plus 2x. I can factor a 3x out there, which would make that an x and a minus 2, and that a minus 1. So that factors to a 3x minus 2 and an x minus 1. And we're going to flip this thing over and multiply. Now I'm going to have to remember some of this. Right? This is 3x minus 2 and x minus 1, so that's going to be important in determining the domain. When I factor this one, get a 3x squared and a 2, so multiply together to give me a positive 6, and they're supposed to add together to give me a 5. So that's a 3 and a 2. 3x and a 2x there, so that's a 3x there would make that an x, and that a plus 1, and that a plus 2. So this is a 3x plus 2 and an x plus 1. Okay. That, when I do the multiplication, is going to end up in the numerator, because I've got to multiply by my reciprocal here, and now I need to factor that top piece. Okay. You certainly could do this factoring elsewhere. I'm just trying to get it all to show up on the video. So I got a 2x squared and a minus 9. Those multiply to give me negative 18 and add to give me negative 3, so it must be a negative 6x and a positive 3x. If I pull a 3x out of that, then that'll be an x. That will be a minus 2, and this will be a plus 1. So this is now a x minus 2 and a 3x plus 1. Okay. And so my domain on this is going to be x cannot equal anything that would have made the original problem have a 0, which would have been a 2/3 or a negative 2/3 because of these two pieces. 1 or a negative 1, so I'll call that a plus or minus 1. And now additionally, now that I've rewritten the problem here, it kicks a 2 into there and a negative 1/3. So there are actually 1, 2, 3, 4, 5, 6 numbers that I cannot use for x in this. And now we'll look to see if there's any simplifying that I can do. And by the looks of it, if I factored everything correctly, there is no simplifying that can be done. Okay, I paused there for a second because I did find a mistake that I made, and it was in this calculation right here. I had written sloppy enough that I thought that was a 3 instead of a 2 there. So this is a 2x, and that would make that a minus 3, and so this would be a plus 1x right there, 1 times x, and that is finish explaining that. This was a minus 3x down here because it gave us the, I had a positive 6 negative 6 and a positive 3. So that's a plus 3x. This would have to be a plus 3. That was how I factored that. So this is actually a 2x plus 3 and an x minus 3. So I think that was these two numbers down here that need to be changed in my domain now. This is a negative 3 halves and a positive 3. And now I do have some things, at least the 2x minus 3 cancels with this 2x minus 3. And I really don't see anything else. Actually, this 3x minus 2, that wouldn't give me a minus 2. So that would have had to been an x plus 1 there. So this actually should have been an x plus 1, which means that positive 1 was not a problem. Only negative 1 was a problem, and the x plus 1s will cancel. And so what I'm left with is an x times 3x plus 2 over a 3x minus 2 times x minus 3 as a simplified version of that with this as the domain. Okay. Took a little while to get there. You can see how you've got to be careful, definitely with things along the way. All right. Let's take a look at the next problem as much as we can see it here. Again, this starts with a looks like 3x cubed minus 12x. So I'm going to rewrite the problem so we can see it a little bit better. Over 2x squared minus 6x plus 4 times 4 times, I'm going to factor the 4 out of there, make that a 4 times x minus 1. I can factor an x out of this and make that an x times an x plus 2. Okay. And there's more factoring that I can do. This one has greatest common factor up here of 3x. So I can make that a 3x times an x squared minus 4 times 4 times x minus 1. All multiplied together in the numerator. In the denominator, I need to factor this one. I can pull a 2 out of there and make that an x squared minus 3x plus 2. It had a greatest common factor as well. X and x plus 2 there. All right. X squared minus 4 factors to x plus 4 and x minus 4 times x minus 1. And in the denominator, I've got the 2 and the x plus 2. And if I factor this x squared minus 3x plus 2, that's going to factor into an x minus 2 and an x minus 1. Okay, and this x squared minus 4, sorry, that factors to an x plus 2 and x minus 2 there. So, our domain here, x cannot equal 0 because of that, or negative 2, or positive 2, or positive 1. So that's our domain. And let's see what we can simplify. I've got an x plus 2 here and x plus 2 there, x minus 2 there and x minus 2 there, x minus 1 there, x minus 1 there. Here's an x by itself with an x by itself. And 4 divided by 2 leaves a 2, so all that's left here is 6. So that simplifies all the way down to 6, as long as x is not 0, plus or minus 2, or 1. All right, 3/5 x plus 5/9 x. Okay, well, we would need if we take out a greatest common factor here, it says it's x times 3/5 plus 5/9, which we can do, has a common denominator of 45. And my numerator, this one I'd have to multiply by 9 over 9, that gives me a 27. This one by 5 over 5, that gives me a 25. 27 plus 25 is 52 over 45, and 52 is 4 times 13, so no common factors with that. That times x, this must be 52/45 x. Okay. All right, finally here, if f of x is 2x over x plus 5 and g of x is 3 minus x over x plus 2, then what is the domain of f of x times g of x? Well, multiplying those together, the x minus 5 would end up in the denominator, so x cannot be 5, and x cannot be negative 2. In fact, no matter what's involved, if these two functions are involved, we know that x cannot be negative 5 or negative 2. That's a little inconsistent with the way that I've been writing it. I would have just said x cannot be negative 5 or negative 2. Okay. Now, when we do the division, the f of x divided by g of x, that's going to be 2x over x minus 5 times x plus 2 over 3 minus x. And now, in addition to x not being able to be 5 or negative 2 because of the original functions, the division puts the 3 minus x in the denominator, so it also cannot be 3. Okay, so stalled out a little bit in the middle there with some mistakes, but that happens. Pays to check your work. So that is the multiplying and dividing rational expressions worksheet.